Then now let us understand the extraction of copper from copper oxides. See, we mainly know copper exists in the form of the sulfide ores, which when the roasting is done for them gets converted into their oxide and SO2 is released. Now thermodynamically, if we see the delta G naught values, what we find is this cuprous oxide can easily be reduced by using coke into crude copper and carbon monoxide. Very easily at below an average temperature of 800 Kelvin. So thermodynamically, this process becomes very much feasible when it is done along with coke. Now, but mainly we need to understand that since the copper ores contains iron oxides as the major gang particles, what we do is normally is that the silica is also added along with the coke. The reason is because it combines with the FeO and forms FeSiO3, the slag, which is being separated out. So this is what is normally done for specifically for the copper ores, and this is how it is usually being reduced to the crude copper. Now let us understand the extraction of zinc from the zinc oxide. See, the zinc oxide can be reduced to zinc by using coke, and this is mainly done at a very fairly high temperature of around 1400 Kelvin. 1400 degrees Celsius, sorry. So the main purpose of doing at such a high temperature is that because what happens is zinc being a volatile compound, when heated at such a high temperature with what coke, so we can write here coke, so it gets directly reduced to zinc and carbon monoxide. This zinc, because at a fairly this high temperature, is changed into the vapor state where it is distilled off and it is reduced, actually condensed by rapid chilling process. So initially the zinc oxide is taken in the form of bricklets along with coke and clay, heated at such a high temperature with coke. So because this coke is acting as a reducing agent, it reduces into zinc, which is distilled off and is actually reduced and solidified by rapid chilling process in the form of bricks. So this is how we extract zinc from zinc oxide.